Hello, welcome again. We are solving some questions of thermal engineering. The topic is IC engine, gas turbine and compressor. Question number 36 is the order of value of thermal efficiency of auto, diesel and dual cycle when they have equal compression ratio and heat rejection is given by option A, efficiency of auto cycle is greater than efficiency of diesel cycle greater than dual cycle. Option B, efficiency of diesel cycle is greater than dual greater than auto. C, efficiency of dual cycle is greater than diesel and then greater than auto. Option D, efficiency of auto cycle is greater than efficiency of dual efficiency of diesel. Okay, so this is your so now the condition is having equal compression ratio and heat rejection. Okay, so heat rejection is same. So in all the three cycles, so phi 1 is your common process for all these systems. Okay, that is heat rejection. 1 2 is your constant volume heat. Sorry, 1 2 is your isentropic compression, and for the auto vehicle 2 6 b should be your constant volume process. So this is your 2 6 is your constant volume process, and this is your isentropic expansion, and then heat rejection. Okay, so this is your uh, constant volume heat addition, and this is your again 2 3 is your constant volume heat addition, and this is your constant pressure heat addition. So this is your dual cycle, and 1 2 6 5 makes auto cycle, 1 2 3 4 makes diesel cycle. 1 2, now this is your constant pressure process. 1 2 7 5 makes diesel cycle. Okay, so as the slope of constant volume line on TS diagram is more than constant pressure line, starting with the same temperature we will, so this constant volume will go to higher temperature. Okay, so it means the heat addition during the constant volume process will be more as compared to constant pressure process, and 2 3 and 3 4. Okay, so this is your constant volume heat constant pressure addition. This is your constant volume heat addition. This is constant pressure addition, and this is again constant volume heat addition. So so auto cycle will have more efficiency as compared to dual cycle as compared to diesel cycle, because here heat is higher, here heat is lower, and here heat is least for the same heat rejection and for the same compression ratio. Okay, so answer is your D. Auto cycle have higher efficiency as compared to dual cycle as compared to diesel cycle. Okay, question number 37. The order of value of thermal efficiency of auto, diesel and dual cycle when they have same maximum pressure and heat reaction is option A, auto cycle has greater than diesel than dual. Option B, diesel cycle has greater than dual than auto. Option C, dual has greater than diesel than auto. Option D, auto has diesel than dual than diesel. Okay, so now the condition is same maximum pressure and heat rejection. Okay, so same maximum pressure and heat rejection. So this is your phi 1 is your constant volume process. Okay, should be like this. Constant volume heat rejection, and now the same maximum pressure. So to have same maximum pressure and equal heat rejection. Now let us consider this diagram. 1 2 is your sorry 1 1 6 is your compression process, and 6 4 is your heat addition process, and this is your again expansion process. So this constitutes auto cycle. Okay, and again this constitutes auto cycle. So auto cycle and heat rejection is same, and maximum pressure is also same, and this is 1 2 3 4 constitute your 1 2 3 4 5 1 constitute this is isotopic compression, this is constant volume, this is constant pressure, and this is again expansion. So it constitutes dual cycle now. Okay, and 1 7 4 5 1 constitutes diesel cycle. So we can see that the heat supplied is during process during during this the area of the uh, Otto cycle diagram is least, and area of the for same pressure. Okay, and area of the dual cycle is in between, and area of the diesel cycle is maximum. So efficiency of the diesel cycle will be more, and then or then dual and then auto. So for and heat rejection is same. Okay, and area is more for diesel than for dual than for auto, and area required work done. Okay, so heat supplied minus heat rejected is work done. So heat supplied will be more for diesel cycle, and then for dual cycle, and then for auto cycle. So efficiency will be in this order. Okay, so answer to question number 37 is D.